Okay, our second video for chapter 16, we left off at On Your Own 16.2 G. Okay, so we've got a rule, so we've got ClNO. We have a rule for oxygen. That one is -2. So for chlorine and nitrogen, I don't have a hard fast rule for either one of those. What you want to do is go to Rule 7. And you need to apply Rule 7 to the most electronegative of the two that's left, chlorine and nitrogen. And remember, electronegativity increases as you go to the right and up on the periodic table. So the most electronegative of chlorine and nitrogen is chlorine. And the charge that chlorine would develop, since it's in column 7, it wants to gain 1 electron, is -1. Alright, so what is nitrogen going to be? Well, we have -1 for chlorine times 1 chlorine atom plus an oxidation number for nitrogen times 1 nitrogen atom plus an oxidation number for oxygen, -2 times 1 oxygen atom, and that has to add up to the charge, which is 0. -1, -2 makes -3, so nitrogen needs to be +3. Alright, so there we go. Alright, H. H is one that accidentally gets missed, and it's so easy, but it's just a singular compound, S8. You've got to go to Rule 1. It's not with any other atom, so it's the charge divided by the number of atoms. So Rule 1. So that's going to be, the charge is 0 over 8, which is 0. So the oxidation number for S8 is 0. Alright, I hope that, go back and watch it again if you need to. Read through the blue example problems on the prior pages. They're great. Alright, let's move on in our notes. Okay, so we are down here underneath H, redox reaction. Oxidation is the process by which an atom loses electrons. Reduction is the process by which an atom gains electrons. The way you can remember that is the Leo the lion. Leo says grr. Loss of electrons, oxidation. Gain of electrons, reduction. Literally, when I was in high school chemistry in 1983, and even 1982, 83, when I was in the 10th grade, we used Leo says grr all the way back then. So somehow it hasn't gone away. Alright, want to make up your own a little acronym to remember? That's fine. But Leo says grr is what I'm going to use. So to determine whether or not an atom is oxidized or reduced, we analyze how its oxidation number changes. Okay, let's look at On Your Own 16.3 on page 532. It says an atom changes its oxidation number from +5 to +1. Was it oxidized or reduced? Well, the number got smaller. The number got smaller. Okay, so it gained electrons. It became more negative. If the number got smaller, that just means it's reduced. By how many electrons? +5 to +1 is 4 electrons. And the way you can write it is just 4 E minus. E minus just is chemistry for electrons, and it was 4 of them. 16.4 says that an atom goes from oxidation number of -6 to -3. Was it oxidized or reduced? Well, it's becoming less negative. It was -6, now it's -3. That means electrons went away. It lost electrons. Okay, so it's oxidized. If the oxidation number is getting bigger, getting larger, it means it's getting more positive. That means it loses electrons. Loss of electrons, oxidation, and there was 3 of them. -6 to -3 would be 3 electrons participated. All right. Next bullet. A redox reaction is a chemical reaction where oxidation numbers of at least 2 atoms change. Okay, so we're going to go through some redox reactions. So this next on your own, also really important. We're going to use the skills that you learned in 16.2 to do 16.5. Alright, part A. We've got copper, 2+. I'm not going to put the phases in. The phase will matter when we're doing batteries, but right now, no. Plus zinc makes zinc 2+ plus copper. So we need to go through the oxidation numbers, and if the oxidation numbers change, then it is a redox reaction. Okay? And we also need to tell which one of the elements was oxidized and which was reduced in terms of the reactants. Okay, so copper. Copper by itself, charge divided by the number of atoms. So that's 2+ divided by 1. Oxidation number is +2. For zinc, charge over the number of atoms. The charge on zinc is 0. For zinc 2+, charge over number of atoms. Charge is +2, 1 atom. Copper, charge over the number of atoms. Charge is 0, 1 atom. So it is a redox reaction. So we'll go ahead and call it a redox reaction. All right, and which one was oxidized and which one was reduced? Well, copper went from +2 to 0. The oxidation number went down, so copper was reduced, meaning it gained electrons. Well, if you have reduction on one, the other one's got to be oxidation. Okay, so 0 to +2 means it lost electrons. The number got more positive, so that loses electrons, which are negative. So zinc is oxidized. All right, part B. Okay, we've got 2H2O makes 2H2 plus O2. Okay. We have a rule for oxygen. It's -2. All of this has to add up to 0. We have a rule for hydrogen also, +1. For hydrogen by itself, rule 1, charge divided by the number of atoms. The charge is 0. For oxygen by itself, charge divided by the number of atoms. The charge is 0 on O2 by itself. Okay, so did the oxidation numbers change? Yes, they did. So it is indeed a redox reaction. Hydrogen went from 1 to 0. Its oxidation number was reduced. So it gained electrons. Oxygen is the other one. You can't have one without the other. So oxygen is oxidized. -2 to 0. It lost electrons, became more positive. Alright, part C. NaCl, NaCl, plus silver fluoride, AgFa, makes AgCl, right? Silver chloride plus NaF. In chemistry, they actually call sodium fluoride NaF. Makes sense. Okay, we have a rule for sodium. Column 1 +1. So chlorine has to be -1 for that to add up to 0. Fluorine, we have a rule. Fluorine's always -1. So silver has to be +1 for that to add up to 0. For silver chloride, we don't have a hard fast rule for either, so we have to go for rule 7 for chlorine. And chlorine is in column 7. It's more electronegative, so it's going to be -1, so silver is +1. And for NaF, you've got -1 on the fluorine. That means we have to be +1 on the sodium for that to add up to 0. So this is not redox. None of the oxidation numbers change, so we don't have to say one is oxidized and one is reduced, because that didn't happen. Alright, part D. Alright, I'm going to hold off if you need to pause the video. Okay. Okay, we've got calcium plus 2HNO3. Anybody remember the name of that? I'll hold off for just a second. You see if you got it right. NO3 2. I bet Kennedy remembers. Plus H2. It is nitric acid. All right, calcium in column 2. So we got a rule. +2. All right, we've got rules for hydrogen and oxygen. Nitrogen is a wild card, right? It's one of our wild cards. So we've got, don't worry about the 2 out front, okay? Don't worry about that. We're only worried about the compound itself. So we've got +1, and -2 times 3 is -6. This has to add up to 0, so nitrogen would have to be +5. Alright, 1 times 1 plus 5 times 1 plus -2 times 3 has to add up to 0. Okay? Write it out like we did on your own 16.2 if you need to. Alright, for calcium nitrate, we've got -2 for oxygen, +2 for calcium, and I'll get nitrogen there in a minute. This one's going to be 0. Charge divided by the number of atoms. Okay, be careful, it's not +1, it's not in a compound. Okay, so for calcium nitrate, I'm going to go ahead and write this one out. It's going to be +2 for calcium times 1 plus some blank, and then we've got 6 oxygens, alright, some blank times 2 for nitrogen, excuse me, plus 6 oxygens times -2. -2 times 6 oxygens. That has to add up to 0, the charge on the whole thing. So that's -12 plus 2. So this whole thing needs to be -10, excuse me, +10. So that would have to be +5, right? 2 plus 10 minus 12 is 0, so +5. Okay, so what do we got here? Calcium did not change. Hydrogen did change. Oxygen didn't change. Calcium, actually, I was wrong. I admit it, Daniel. I was wrong. Calcium by itself is 0. Okay, so how did I figure that out? Okay, I figured it out because I knew that hydrogen, which went from 1 to 0, I knew it was reduced. So I had to have oxidation, and I couldn't find one. I couldn't find an oxidation. Okay? And so then I started looking, alright, I must have messed something up somewhere. And then I saw, oh, dadgum, Cheney. It was calcium. Alright, so calcium by itself is going to be 0. In a compound, it's going to be +2. So calcium is oxidized. And this, if you have oxidation and reduction, then it is indeed a redox reaction. Alright, so this is a good place to stop this lecture. What you can do right now, the problems that you can work are review questions 1 through 5, and you can work practice problems 1 through 7. You've got enough knowledge to do that, so before you work the next ones, you might want to go ahead and give those problems a try, and then we'll come back and do the next lecture or two, and you can finish up the chapter.